All right, we're going to start chapter 12, which covers quadratic equations. I think there's more on the square roots that we really need to do, but we're not going to have time. And there was something on dimensional analysis I really wanted to do, but that one, anyway, we're pretty much out of time and it's been a weird quarter. So moving on to quadratic equations, I want to give you, before we go into section 12.1, I want to give you just an overview of quadratic equations in general. This is what their format is. If you ignore the equals 0 part, what you have here is a polynomial of the type that you would normally factor. So like on your last test, these are the kinds of things you were factoring. The highest exponent would be a 2. As a matter of fact, it has to have a 2 to be considered a quadratic equation. If you have a cubed or a fourth power somewhere, it's not quadratic. If you think of a line, y equals mx plus b, the highest exponent on a straight line would be x to the first power. So x to the second makes it quadratic. And then if you put an equals 0 on it, it becomes an equation. Now, quadratic equations, their graph, and we're probably not going to be able to get too much into the graphs, which I was really hoping to do. They look like this. And we touched on these a little bit as far as finding where they intersect the axes, stuff like that. Okay. They make parabolas. That's what the name of the shape is. And this is the general overview on how to solve these kinds. So, to solve, kind of like when we factored, we had a little checklist. This is just, it's not really a checklist, but it's just a list of ways that you could solve one of these. So number 1, just take the square root. This is what section 12.1 is about. This method works if they're perfect squares. So we'll start with this type. Number 2, you could factor it, and we did this a little bit. Factor if factorable. They won't all be factorable. You could complete the square. Not sure how far we're going to get into this because we don't have a lot of time. Or number 4, you could use the quadratic formula. And that's a fun one. The quadratic formula, this one always works. It works no matter what. You may not want to use it all the time, but it will always work. All right, when you solve, I'm gonna go ahead and outline this here, hold on. Okay, you box this up. This is an important little summary there. When you solve a quadratic equation, I know this isn't making a whole lot of sense, it's just an overview. I'm trying to find the x values that make this equation true. And those x values are going to be the x-intercepts on your graph. And we did touch base on that a little bit. Okay, now I'm going to draw a line. And now we're going to start section 12.1. Perfect squares. And I don't mean factoring perfect squares, I mean solving quadratic equations that are perfect squares. And I think we're just going to do examples. Let me highlight so you can see where we're starting here. Okay, example 1. The directions will all be to solve, and some of these are going to be so easy. M squared equals 9. Notice you've got a perfect square here, right? A perfect square here. You always want to make sure you, or almost always want to make sure you get the square term alone. So make sure squared term is alone, meaning on one side of the equation by itself. Now, it's kind of obvious, it already is here, so all you have to do, and I'm just going to rewrite it so you can see, is take the square root of both sides and put a plus minus in front of the square root. Kind of like how we solved those absolute value equations last year. Put a plus minus here. So you get m. If you take the square root of something squared, it cancels it. So you get an m out equals positive and negative 7. Those are my two answers. Now, what does that mean? It means that if you were to graph this, the 7 and the negative 7 are the x-intercepts. And it looks like that, except not so crooked. All right, example 2. Try to keep that straight. 5r squared equals 45. Now there's a couple weird things with this equation. First of all, the squared term isn't alone, and this is not a perfect square. So if I want to make sure I get the r squared by itself, I need to get rid of this 5, right? Divide both sides by 5. So I get r squared equals 9. Now, I'm going to write this again. Make sure squared term is alone. All right, now take the square root of both sides. As long as you do the same thing to both sides of an equation, you haven't affected the balance. Put a plus and minus in front of the square root. I'm going to highlight that. That is important. Put that guy there, that guy there. So we get r equals positive and negative 3. Those would be the x-intercepts if I were to graph this parabola. Okay, 3, negative 3. They're not always symmetrical about the y-axis, but these simple ones, a lot of them are. And it would look like that. Okay, next side, they do get weirder. Example 3. Yeah, I guess, you know what? I'm going to change this. I'm going to go to this side. It's a little easier to read. Okay, let's have x plus 6 squared equals 64. Well, let me rewrite this. I have this, the square term is alone, right? So we're good there. Square term is alone. So all I need to do is take the square root of both sides, put my plus minus in front of this side, And the square root's going to cancel the square, so what I have is x plus 6